Intro to derivative by limit process. This problem never intended to be a limit process problem, but it turns out to be one. So can we just take a look at this really quickly? And I think that you'll really get this. So here's what we have. We have f of x here. And if you look over here, f here, yeah, and f here. So what I'm going to do here is this. I'm just going to rewrite this portion right here. And every place that I found x, right? Think of it this way. If we had f of 3, every place that you found x, you'd put a 3 in, wouldn't you? Well, here they're saying every place that you find an x, put in x plus h. So I'm just going to set this thing up. I'm going to rewrite this, and I'm going to take this. I'm going to work on this piece right here. This is where I am right here. I'm going to take this, and I'm just going to build this piece. And I think it's built like this. So it's f of, so 1 over, here's where I found that x, right? Here's this x I'm looking at right here. So it says where you find an x, but x, I'm sorry, here. Put an x plus h, so I'm going to put x plus h plus this 2. Plus this 2 right here, okay? And then this negative sign, you guys, is this one. And then f of x, this f of x right here, this f of x right here, is this f of x, isn't it? So minus 1 over x plus 2 all over h. So now I have this, I've made this into a composite function, haven't I? So here's the problem. This can be simplified. We can put these two fractions together by finding a common denominator. And all I'm going to do here is this. On this side, I'm going to multiply this side by x plus h plus 2. That is the denominator of this side, over x plus h plus 2. Right? And this side, right, this side, I need this denominator to be part of this one. So I'm going to multiply this side over here by x plus 2 over x plus 2. And if you think about this, again, of course, we're just multiplying by 1, so that's why that's okay to do. So I'm going to start my rewrite. One thing I'm going to do, I'm going to multiply this 1 times this, and I'm going to get x plus 2. Yeah? Remember that this piece right here is a negative 1, isn't it? So negative 1 times x is negative x. Right? I'm just distributing into here, here, and here. Negative, right? Remember the negative. Negative 1 times h is negative h, isn't it? And negative 1 times positive 2 is negative 2. Is that all right? And then, of course, we have common denominators, right? We have a denominator here of x plus 2 times x plus h plus 2, and we have the exact same denominator over here, so I'm just going to carry that over. Now, what a lot of you I know are thinking, do you have to simplify this? You have to expand this, and you do not, unless your professor tells you otherwise. I certainly wouldn't do it, because there's no good reason to do it. If you look at this solidus right here, this fraction bar, whatever you want to call it, that's right here, isn't it? Right? So I'm just building this thing as I go. So far, so good, I think. And now we're just going to simplify here a little bit. So let's simplify. And we have x minus x, x minus x. We have 2 minus 2, right? So I'm just going to do another rewrite, and I'm going to take this, just rewrite this. All we had up here was the, right, is this negative h, didn't we? So here's our negative h right here. Here's our solidus, or our fraction bar here. I am not going to expand this. There's no reason to expand it. Plus 2 here, right? All over h, right? Here's the part. It's not tricky, but it bothers people a little bit, because when you look at it, you're trying to figure out, well, what am I supposed to do next? Well, what you're supposed to do next is realize that this is really a complex fraction. So this is complex fraction. And please remember that to solve a complex fraction, it's a over b over c over d. What you do is you take a over b times the reciprocal of this piece down here, which is d over c. And sorry, this is a b here, isn't it? B. Okay? So that's what I'm going to do here. I'm going to rationalize this h, which is just h over 1. And then if you don't mind, I'm just going to start applying this theorem to that. And we had this, right, this negative h all over x plus 2 x plus h plus 2, right? Times, and remember I said we're going to take the reciprocal of the bottom piece, right? That would give us 1 over h. And hopefully you're seeing that this 1 is this one, this h is this one, right? I took the reciprocal here. Now look what happens. Let me make sure this looks like an h. H goes into itself once, so this becomes negative 1, doesn't it? Right? This becomes a 1. And negative 1 times 1 equals negative 1 all over x plus 2, x plus h plus 2. What would I do differently? I might put this out here. Whoops, I might put this negative sign out front. Do you have to? Of course you do not have to, but just thought I'd give you all the ideas that I have. I really hope this was helpful to you. This stuff can really be done. This is really just composite functions, and it's something that with practice will get very, very straightforward and easy. If you have any comments, please let me know, and I appreciate it if you subscribe to my page. Thanks.